Okay, so let's start with today's lesson. So today's lesson will be the first lesson of your Cambridge A-level chemistry. Okay, so there's a few things that I want to make it clear before we proceed. Number one, okay, now you guys are already in pre-U level, okay, so I do have some expectation lah. So I do expect that you guys should be able to study more independently, as in, I don't expect. Okay, I didn't wish that you guys are spoon-feeded. Expect the tuition or the college will show you everything step by step what you should do. Okay, I expect you should be like more active or more self-disciplined in your study lah. Okay, so that's the first thing. All right. Number two. Okay, number two. All right. In A level, okay, the main sources of exercises you should practice is your past year question. And it is very easy to get the past year question for the A level. Yeah, basically you just simply type 9702 a past year question in Google, and you were able to gain access to many past year questions. Okay, so it's very easy to do the past year question. Okay, so this is very different compared to what you guys learned, let's say back in your SPM or IGCSE. Because back in your high school, maybe you only do the past year very last minute. Maybe you only do the past year very last minute, coming toward the end of your entire syllabus, then only you do the past year question. If you're still having this habit in your A level, you will struggle a lot. Okay, so that's something that you have to like constantly practice on the past year question. Okay, and when you are doing past year question, you must always start from the latest one. Example, okay, let's say today, if you want to do the past year question, the latest paper you can probably get is maybe May-June 2024. Yeah, because the past year question for October, November 2024 is not yet, all right? So the latest paper you can get is May-June 2024. Then you work backward. Then the next question you do October, November 2023, May-June 2023, and so on. So when you are practicing on past year, always start from the latest one. That will be good enough already. Okay? So then the third thing is that if, let's say, back in your high school, you study very last minute, you study last minute and you still able to pass your exam with flying color, not for A level. Yeah, A level you couldn't chill one. You couldn't chill. You have to start working very hard first week when you started with the program. Okay, you cannot say, oh, I chill first, because A level, everything go very deep, everything goes so much deeper, and the time is not sufficient one. The time is not enough one. Okay, so you couldn't like, oh, I want to be chill, I want to relax first in A level. You will struggle a lot. Okay, so in A level, I will suggest that all of you must always know what you want to learn in each chapter. The simplest thing is that you always go to Google. You go to Google, and then you type this. Okay, 9701. This is the code number for your A level chemistry and syllabus 2025. So, and then you can download the first PDF file, and then you should be able to see something like this. Okay, so this thing will actually list out the syllabus content. Yeah, the syllabus content. Okay, example, you see, let's say now this is what you will learn in your AS, and this is what you will learn. This is what you will learn in your AS. AS is on the left hand side, and the A2 is on the right hand side. Yeah. Then after that, okay, this is like, for example, let's say for one particular chapter. Okay, let's say chapter 1, atomic structure. These are all the learning outcome. Yeah. So if you really want to know whether you are okay or not, always ask yourself, number one, are you able to understand that atoms are mostly empty space? Okay. Are you able to identify and describe proton, neutron, electrons? So this is like a checklist. After you completed like one chapter, always refer to this learning outcome. You ask yourself, you know, have you achieved the desired outcome or not? Do you really know what you need to know or not? Yeah, so this is very important. Okay, all right. So we will start. Today's lesson will be relatively easy in the first part. Yeah, because most of the thing in the first part we learn it. But coming toward the second part of today's lesson, you will learn something totally new that you never learned back in your SPM or even IGCSE. So I want two things from you only. Number one, I want you to stay focused. I want you to stay focused, okay, and try to listen to what I'm going to say. Yeah. So, and don't be easy to copy all these things because the notes will be provided to you. I'll give you the notes right after each lesson. Why I want to give you the notes after the lesson, not before that, because I will do a lot of annotation. I'll do a lot of writing during the lesson. Yeah. So that's why after I annotated the whole thing, then only I can send in the notes. So you will get the notes right after each lesson. So that is the first thing. Okay. Then the first thing I want you to focus. Number two, the second thing is that I want you to actively ask questions. If there's anything you're not sure, please, please, please ask question. Please ask, okay? Don't feel that you are asking some very easy question, you're asking some stupid question. No, don't ever have that kind of feeling. Anything not sure, just ask, okay? I hope that after each lesson, you are crystal clear about what you're going to learn, okay? Right, so without further ado, let's start with today's lesson. So for the first lesson, I really need you to know all this, like house rule. At least you know what to expect. Okay, really want you to know that first. Okay. Out of curiosity, any one of you who actually attended any of my lesson before? Any one of you? If you attended any of my class before, maybe you can type number one in the chat box. Like maybe you attended my e-learning program. Maybe some of you watched my YouTube video before, or maybe you attended my Zoom class before. Anyone? Okay, probably you can let me know. Okay. So, without further ado, let's start with this lesson. Okay. So first of all, today we will learn something about atomic structure. Atomic structure. So what is atomic structure all about? So atomic structure tells us atom is the smallest particle. So how many types of particle we have in chemistry? Three types of particle. So we have three types of particle in your chemistry study, which is atom, molecule, and also ion. Okay, we have atom, we have molecule, and we have ion. So make sure you all know the differences between atom, molecule, and ion. Atom is anything who come alone. Example, carbon, zinc. So they are alone, they are atom. Molecule, it's non-metal and non-metal combined together. So when you have non-metal and non-metal combined together, so it is a molecule. Ion is referred to somebody got charged. Somebody got charged. That is called ion. So this is something you learn back in your high school, okay? So not very hard. So atom is the smallest particle. So we won't be able to find anything smaller than atom. All right. So some students will say, sir, what about ion? What about electrons, proton? Isn't that they are smaller than atom? Yes, they are smaller than atom, but we don't call them as particle. That's why you all must be able to differentiate particle and subatomic particle. So particle, okay, is referring to your atom, your molecule, as well as your ion. Subatomic particle is what? Something inside the atom. Something inside the atom, which is proton, neutron, and electron. Okay, so but atom is smallest particle. If something smaller than atom, not even exist. But if you go into the atom, if you go inside, if you go into the atom, then you were able to find something called subatomic particle. So please make sure you all know the differences between particle and subatomic particle. Okay, all right. So yeah, this is what we need to know. Okay, so atom. So inside atom, we have three subatomic particles, which is called proton, neutron, and electron. We have something smaller inside an atom, which is called proton, neutron, and electron. So make sure you know the name and the symbol. Proton is P, neutron is N, electron is E. Yeah. So what is the mass for proton? 1. Okay, it's only 1, unitless, no unit at all. It's not 1 gram, it's not 1 kilogram, just number 1 only, no unit at all. All right. So what is the mass of neutron? 1. So proton and neutron, they have exactly the same mass. What is the mass of electron? 1 over 1,836. So what does this number tell you? electron is very, very light. Electron is very, very light. Okay, you need about 1,836 electron. Then only the mass is equivalent to 1 proton and 1 neutron. So electron is super duper light. Okay, next one is the charge. Every proton, the charge is positive 1. Every neutron, no charge, and every electron, the charge is negative 1. You need to write the number because a lot of students are very careless. When the question asks, what is the charge for proton? Many students only write positive. Wrong. Positive 1. So you need to put in the sign as well as the number. Yeah. And make sure you know the location, where to find them. Proton and neutron, you can find them in the nucleus. Nucleus is the center of your atom. Electron is outside the nucleus, and the electron, they are moving in shell. Electron, they are moving in shell. Okay, so this is not very hard. This is warm up. This is we are trying to warm up. All these things are super, super easy. Okay, so later we will increase the difficulty step by step. We will increase the difficulty step by step. Okay, all right. So make sure everyone know atom is the smallest particle. Inside atom, we have proton, neutron, electron. So make sure you know the mass, you know the charge, and you know the location to find the proton, neutron, and electron. So that is the first part. Okay. All right. The second thing, we need to do a very important experiment. We need to do a very important experiment to know the behavior of the subatomic particle. So the subatomic particle, they have some behavior. Okay, so what is it? Look at here. Okay, so today, if you have this is, we call electric field. Electric field. This is the plate. So here it's minus and positive. Can we make it opposite? Can we put positive on top and negative at the bottom? No problem. Okay, as long as they are oppositely charged. So now we will try to let proton, neutron, and electron to pass through this electric field. This is called electric field. So you need to know a simple thing. So now we will just imagine there's a gun, but the bullet of the gun is a proton, neutron, or electron. Okay, so when we try to shoot the proton going through the whole thing, going through here. So let's say we shoot from here, the middle. This is the midpoint. We started. Okay, when you shoot the proton, you will realize that the proton go and bending toward the negative pole. Makes sense? Okay, so what does this prove? Why it doesn't go straight? Why the proton, when you're moving and bending a little bit toward the negative pole? Because we know proton is positively charged. So when you are positive, you will be attracted toward the negative terminal. That's why it will bend a little bit. All right, so this fella is your proton. So if you shoot the neutron will just go straight without any bending. Makes sense, because neutron is neutral, don't have any charges, so it won't attracted to positive or negative terminal at all. What about electron? Electron, when you shoot it, you realize that electron will bend to the positive pole, and the electron will bend like crazy. Can you see? The proton bend a bit only, but the electron bend a lot. Why? Okay, so here we have two findings. Okay, why electron bend to positive terminal? Because electron is negatively charged. When you are negative, you attract to positive. That's why you bend to the positive side. Next one. Why the bending angle? Why the bending angle for electron is so big compared to the proton? Because electron is very light, isn't it? Look at the mass. Electron is super, super light. So if you're heavy, very hard to do the bending. When you are very, very light, you can bend like crazy. You can bend a lot. Okay. So this experiment tell us, okay, you can see neutron have no deflection at all because it is neutral. Neutral do not attract toward positive or negative terminal. Proton bending toward negative pole, it proves that proton is positively charged, isn't it? So electron is negatively charged, it will deflect toward the positive plate, and the electron is very, very light. That's why it deflects much, much more compared to the proton. Okay, guys, let me know in the chat box, are you okay with this experiment? Do you understand what is this experiment all about? Can you please let me know in the chat box? Okay, so now we're done with this, okay? So now this is the first thing we learn. Okay, so the next thing, what should we know? All right, so we will need to learn about standard representation. So standard representation, again, is nothing new. This is something you learn back in your high school. No matter you are doing SPM or IGCSE previously, you learn about this. What is standard representation? Standard representation is a method, is a format for us to write chemical substance in periodic table. So basically, in periodic table, we are representing the chemical substance using standard representation. So how does the standard representation looks alike? So you will see a big symbol right in the middle, and then there are two numbers. On top here, this is a big number. At the bottom here, this is a small number. Yeah, big number on the top, small number at the bottom. Okay, all right. So the small number, it's called proton number. Proton number has another name, which is called atomic number. Some students, they don't know. Actually, atomic number is the proton number. They are the same thing. Yeah, they just use different name. The big number on top here is called nucleon number. Nucleon number, another name called mass number. Yeah. So make sure everyone know. The proton number, same meaning as atomic number. Nucleon number, same meaning as mass number. Make sure everyone know that. And what does the proton number tell us? Proton number tell us the number of the proton in the nucleus. How many proton we have inside the nucleus. All right. So now, what is the nucleon number? The number of proton and neutron in the nucleus. Okay. So make sure everyone know what does the nucleon number represent and what does the proton number represent. Example, you can see this is a example for standard representation. So this fella is a sodium. It has 11 proton. So the total number of proton and neutron add together is 23. Yeah, not very hard. So when you are given standard representation, when they give you standard representation, we always able to get three information. We always able to extract three information from the standard representation. What is it? We were able to find the number of proton, the number of neutron, and the number of electron. So when they give us standard representation, we will be able to get how many proton, how many neutron, and how many electron. Again, this has nothing to do with A level. This is something purely you learn back in high school. That's why for today, the first 30 to 40 minutes quite easy, honeymoon period, because most of the concept you learn back in high school, but only 30 to 40 minutes. After that, you will learn something entirely new, which you never encounter back in your high school. Okay, all right. So let's look at here. So this one, just do a very quick revision. So if you're given this fella, how to find the proton number of proton, neutron, and electron. So proton always take the small number, all right? Neutron always take big minus small number. I believe you all know this. Electron, you have to check. Electron, you have to be super careful. If the substance is neutral, then the number of electron will be exactly same as proton. If the substance is neutral, the number of electron will be exactly same as the proton. So in this case, the potassium is neutral. We don't see any charges. So when it is neutral, the number of electrons should be exactly same as the proton, which is 19. Okay, so I hope everyone know how to get the number of proton, neutron, and electron for potassium. So let's increase the difficulty. What if now the particle got charged? When particle got charged, it will be slightly tricky, okay? What if today we got some ion? What if today there is some charges. There is some charge coming in. Okay, so when we have charge coming in, so what should we do? What should we do? All right, so now same thing, proton still the same. When you proton always take the smallest number, no matter it has charge or not. We don't care whether it has charge or not when you come to proton. Proton always taking the small number, so it's still 13 though. Neutron also don't freaking care about the charges at all. Neutron don't care. I don't care if you got charge or not. Neutron forever just take the big number minus the small number. So 27 minus 13, you got 14. Now the tricky part is electron. So remember, electron normally same as the proton when it is neutral. So you have 13 proton, by right, you should have 13 electron, right? But no, you only have 13 electron when you are neutral. But now you are not. Obviously, you are not neutral. So when you're not neutral, what to do? So you need to do something about the electron. So we learned back in high school. When you are a neutral atom, when you are neutral in the first place, when you go to donate, or we call lose, or we call release electron, when you throw the electron away, then you will become positive ion. Example, I am neutral, I donated 2 electron, I become ion, and my charge is 2 plus. Okay? If I am neutral, I donated 1 electron, I'll become an ion, my charge is 1 plus. Okay? So when the neutral atom go to receive, or you can say gain, or you can say accept electron. When you accept electron, what happens? You will automatically become negatively charged. You become a negative ion. Example, I am neutral in the first place. I receive 3 electrons from other people. I will become an ion. The charge is 3 minus. So make sure everyone know this. So by right, when I got 13 proton, by right, I should have 13 electron. But now I know my charge is 3 positive. So when you see positive charge, how to get something positive? You must donate electron. Remember, donating electron become positive, receiving electron become negative. So 3 plus means what? This fella need to donate 3 electron. So you have 13 electron in the first place. After you donated 3 electron, you become 10. So the number of electron supposed to be 10. Okay? That makes sense because you see, 13 proton, what is the charge? Every proton, the charge is positive 1. 13 proton, the charge is positive 13. 10 electron, every single electron, the charge is negative 1. So you have 10 electron, negative 10. If you add together, the charge is positive 3, which actually matching. Yeah? All right. So we go one more example though. One more example. What about this? So today, if I have a chloride, so guys, can you please give you a 1-minute self-test? Can you tell me how many proton, neutron, and electron you have? Can you please type in the chat box? Tell me how many proton for this chloride ion, how many neutron, and how many electron for this fella. Can you please try to do this and let me know in the chat box as a quick self-test? Okay, all right. So let's have a look. Okay, so let's have a look how to do this. Okay, let's try to see how on earth we can do this particular question. Okay, so okay, all right, proton always take the small number. It is true. Neutron take the big number minus small number. That's it. Electron, watch out. Normally, electron should same as the proton. Normally lah. But electron only same as proton if and only if this fella is neutral. Is this fella neutral? No, this fella got charge and it's negative. So how to become negative ion? Need to receive electron. The charge is negative 1. So you need to receive 1 electron. You have 17. You receive 1 extra electron and you are 18 now. Okay? So that's it. So this is how we find the number of proton, neutron, and electron for the ion. Not very, very hard. Okay. So that's it. Okay. So this is the one I say lah. When neutral atom donated electron, they became positive ion. When neutral atom receiving additional electron, they become negative ion. Okay. So this is nothing hard. This standard representation concept has nothing to do with A level at all. It is something coming from your high school. It is something coming from your SPM as well as your IGCSE. So why I cover this, because if you look at your syllabus content, you can see, okay, your syllabus content, the first chapter, atomic structure, they do ask about that, you see? They ask about, okay, so proton and neutron is in the nucleus, electron is in the shell, okay? So proton, neutron, electron, what is the charge they have and what is the masses they have, isn't it? So what is atomic number, proton number, mass number, neutron number, isn't it? All right. So describe the distribution of the mass and the charge within an atom. So where does all the mass? So the mass is all coming from the nucleus, because inside the nucleus, you have proton and neutron, which is where all the masses are. Electron is outside the nucleus, and electron, they are so light, they didn't contribute a lot to the mass, isn't it? Mass is all contributed by proton and neutron. So if the question asks, what is the distribution of the mass? So you can say, okay, the mass of atom is concentrate, or is centralized at the nucleus. Or you can just simply say, okay, most of the mass of an atom come from the nucleus. Simple as that. All right. Okay, so describe the behavior of proton, neutron, electron beam, isn't it? Electric field, something I showed just now. Okay, so find the proton, neutron, electron, okay, in the standard representation. Okay, all right. So not very hard, right? Not very, very hard. Okay, so that's why this is good. Okay, when you have all these, when you have this checklist, you will know what you need to learn. Okay, you will know what you need to learn. All right, as simple as that, you can see. So yeah, standard representation, all these things. Okay, so now come back to here. Okay, next one. After standard representation, the next thing we need to learn is called isotopes. Okay, isotopes. So again, isotopes is nothing to do with A level actually. All right. Okay, let me get it. I get a question in the chat box. So if question asks, what is the mass of the nucleus? Do we need to do proton mass plus neutron mass? No need lah, no need. Okay. If the question, okay, let's say if the question give you this, okay, let's say the question they give you like this, okay. Potassium 39 and 90, for example. If they ask you what is the mass of the nucleus, then you can just simply write 39, no? As simple as that, no? Because this big number is the nuclear number. Nuclear number equivalent to the mass number. It makes sense. All the masses is come from proton and neutron added together. So the mass is 39, directly like that. Yeah, simple as that. Okay. Okay, so what is isotopes? Isotope is referred to the atom of same element with same number of proton but different number of neutron. Okay, anything which got same number of proton but different number of neutron, we call them as isotopes. Okay, isotopes. And you all have to be careful because this thing, especially for those students who coming from SPM. In SPM, this is a super easy question, but not many people can score in SPM, even though this question is damn easy. Why? Because in SPM, when the question asks, what is isotope? Many students only write, oh, isotope, same number of proton, different number of neutron. Or they say, same proton number, different neutron number, and they get 0. Why? Because isotope, you must write atom. Many students didn't write atom. So the examiner don't know, oh, isotope is an atom. Because if you never tell me how I know isotope is an atom, molecule, or ion, you need to write the word atom. Number 2, same element. You must write the word same element. So I know all isotope come from the same family. So these 2 words is where and why a lot of students lose their mark, especially SPM students. Especially SPM student. Okay, A simple thing, but cannot score because forget to write the word atom, forget to write the word element. So I hope everyone know what to do. If the question asks what is isotope or define isotope, make sure everyone know how to write it. Isotope is atom of same element with same number of proton but different number of neutron. If you don't want to write different number of neutron, you can write different nucleon number. Okay, so that is isotopes. So this is not hard, but you all must be super attentive to the details. You must be super careful with the details. Yeah, so that is very important. Okay, so next one. Okay, now these two fella is example for isotope. You see, chlorine 35 and chlorine 37. Okay, in your chemistry, whenever you see a chemical name followed by a number, whenever you see a chemical name followed by a number, the number at the back always representing the nucleon number. Example, if you see they write carbon 14, it means that this carbon, the nucleon number is 14. Whenever you see any chemical name followed by a number at the back, the number always represent the nucleon number. Okay, so chlorine 35, which means what? The 35 is the nucleon number. Chlorine 37, it means the 37 is the nucleon number. So guys, you are given the chlorine 35 and 37, and these two fella, they are isotopes. Why? They have same number of proton, isn't it? Both of them have 17 proton, but they have different nucleon number, or they have different number of neutron. So neutron, how to find? Big minus small number. So you can see the neutron, they are different. So remember, isotope is atom of same element with same proton number, but different number of neutron, or you can say different nucleon number. Do not ever go to write different neutron number. No such thing. No such thing called neutron number. Okay? Isotopes, since they have same number of proton, of course, the number of electron will be the same. Okay? So make sure everyone know what is isotopes. I repeat one more time. Isotope, they are atom. They are not molecule, they are not ion. Isotopes, they are atom of same element. Same element means what? Same family. Like these two fella, they are isotope, they are both chlorine. They are same element. Isotope is atom of same element with same number of proton, but different number of neutron, or you can say different nucleon number. Okay, so simple as that. Okay, next one. All of you must know isotope have different physical properties but same chemical properties. Isotope, they have different physical properties but same chemical properties. I hope everyone here know the differences between physical and chemical properties, because something quite sad, a lot of students, a few weeks before their final exam, before their SPM, before their IGCSE exam, they still don't know the differences between the physical and chemical properties. So can we do 1 minute revision on that? What is physical properties, everyone? Physical properties is referred to those observable properties, those properties, those character that you can observe. Example, melting point, boiling point, these are physical properties. Density, physical properties. Electric conductivity, color, okay? All these are physical properties. So what is chemical properties, everyone? Chemical properties focusing on reaction. You can combine with who and becoming what. That is called chemical properties. Example, I can react with water to form blah, blah, blah. That is chemical properties. I can react with oxygen and form something else. That is called chemical properties. So I really hope you all know what is the differences between physical and chemical properties. Okay, so now we must know isotope, they have different physical properties. So the physical properties will be different. Example, these two fella, they are isotope. So they might have different physical properties, such as they might have different density. Okay, they might have different boiling point. They might have different density. They might have different boiling point. Okay, different boiling point, BP, boiling point, for example. Yeah. So let me write it up. Yeah. Okay. So they have different physical properties. For example, Okay. So they might have different melting point, different boiling point. They might have different density. Okay. Okay. So they have different physical properties. Okay. Next one. They have same chemical properties. So same chemical properties means what? They can undergo the same reaction. Example, if chlorine 35 can react with water, chlorine 37 can also react with water. If chlorine 35 can react with hydrogen, chlorine 37 can do the same thing as well. Okay, so that is called same chemical properties. And in exam, they always love to ask this question: why isotope have same chemical properties? Why isotope have same chemical properties? Okay, guys, can we do a quick revision? And can I ask you a simple thing? In high school, do you know chemical properties decided by what? If today the question asks, chemical properties decided by what? What will you answer, everyone? Nothing to do with isotope, nothing to do with isotope. I just ask a simple question. Chemical properties decided by what? Anyone? Chemical properties decided by what, everyone? Let me know the answer in the chat box. If today you get a question, what factor determine the chemical properties? What is the factor that determine the chemical properties? What will you write? Come on, let me know the answer in the chat box. Okay, so chemical properties is decided by number of valence electron. So for your information, you learn this in high school. Okay, chemical properties is actually decided, or we can say determined, determined by number of valence electron. Valence electron. If you only say number of electron, wrong. If you only say number of electron, is wrong. Okay, number of valence electron. Okay, so what is valence electron? The outer electron. How many outer electron we have? All right, example. Today you got 9 electron. I got 17 electron. Do we have same number of electron? No. The number of electron is different. I got 9 electron in total. You have 7 electron in total. But look at our valence electron. Okay, I got 7 valence electron, same as you. You also have 7 valence electron. So that's why we have same chemical properties. Okay, you can react with water, I also can. You can react with oxygen, I also can. So remember, chemical properties is not decided by total number of electron. They are decided by how many valence electron you have. And you must write number of valence electron. Some students are extremely careless. When the question asks, chemical properties decided by what? They just write these two words, valence electron. Wrong. Chemical properties decided by valence electron. Wrong. It's number of valence electron. A small details can decide whether you are right or wrong. Understand? You must write number of valence electron. If you only say chemical properties determined by valence electron, 0, no mark at all. So you must be very attentive to some small details. All right. So now come back to here. Why isotope have same chemical properties? They have exactly same number of electron. Therefore, they have same number of valence electron. True or not? Because you see, when you have 17 proton, I also have 17 proton. When you have 17 proton, you have 17 electron. I got 17 electron. So I am 287, you are 287. True or not? When the number of electron is the same, for sure, the number of valence electron will be the same. Okay, that's why in this case, if they ask you why these two isotopes, they have same number of valence electron, you can write they have same number of electron, you'll get the full mark, or you can write they have same number of valence electron, also can. Yeah, finish. Okay, everyone, let me know in the chat box, are you okay with the entire concept of isotope so far? Are you guys okay with the entire concept of isotope so far? Okay, so you see what we learned already? So we already learned isotopes. Okay, what is the definition? So then we also know that isotope, they can write the format, standard representation, why they have same chemical properties, and then isotope, they have different physical properties, such as different mass and different density. Make sense lah, okay? The isotopes, let's say you are chlorine 35, I'm chlorine 37, okay? What is your mass? 35. What is my mass? 37. So when the mass is different, density confirm different, am I right? Because density is mass over volume. So since we have different mass, of course, we will have different density. We will have different density. So as simple as that, okay? Different. So here we try to fit the syllabus. So different mass, different density. So we don't go for melting point, boiling point, since the syllabus content clearly asks us to focus on mass and density. You can see. So that's why you follow the syllabus content, you won't go strong one. Okay, so now you see, all these are done already. So you see, make good use of all this syllabus content. Please make good use of the syllabus content so that you know exactly what you need to learn. So you know exactly what you need to learn. Okay, finish. Okay, now, guys, honeymoon period finish already. So now you will learn something A level. You will learn all these A level things. 1S2, 2S2, 3P6, 3S1. This is A level, or we call pre-U level stuff. Okay, this is some pre-U level stuff. Okay. So now honeymoon period done already. So just now, honeymoon, standard representation, you learned before. Okay. Isotope, you learned before. So those things you learned before, that's why they are honeymoon. But now we are learning something totally new, which I want you all to stay focused. And I happen to know just now that most of you here, you didn't start with your A-level program yet, isn't it? I happen to know that quite a number of you here not yet started with your A-level program. So that's why this might be the first time you learn about it. So that's why I really need you to pay attention. Okay? Come, let's start. Okay. So for the next 1 hour, plus minus, we will do something totally new and quite technical. Okay, I'm going to go very, very, very slow to make sure you understand. So first of all, guys, I want to make sure this whole thing is called 1S2 notation. Do you learn about this thing before? Let me know in the chat box. Yes or no? Do you learn about this 1S2 notation before? Yes or no? Okay, no, all right, no. And it's true, you shouldn't learn about it. No matter you are coming from SPM, or no matter you're coming from IGCSE for your high school, you shouldn't learn about this because it's not in the syllabus. So this one S2 notation only in pre-U studies such as A-level, matriculation, SPPM, foundation study, MUFI, all these things. Yeah, only you learn this thing in pre-university, pre-U, not in high school. Okay, so you see, guys. Now, when you come to pre-U, you will find that many things you learn back in high school, they are not entirely correct. Okay, example, in SPM or IGCSE, let's say the A got 11 electron, how you write electron arrangement back in high school. In high school, when you have 11 electron, we write 281, isn't it? First shell got 2 electrons, second shell got 8 electron, and the third shell got 1 electron. That's it. That's exactly what we learned back in high school, isn't it? No matter you are from SPM or IGCSE. But when you come to A level, after today's lesson, you need to know, 11 electron is arranged in this. 1s2, 2s2, 2p6, and 3s1. totally different. Yeah, that's why you will find that when you come to pre-U study, you will find that many things you learn back in the day, many things you learn back in high school, they are not so relevant already. They are not so relevant. Not to say they are wrong. It's just that now we need to go more advanced already. Now we need to learn something more advanced. Okay. So that's why we need to, upgrade ourselves. Okay. We need to upgrade ourselves. Okay. So let's start. Okay. Let's start with this. Okay. So 1s2 notation is a special, or we call a new method to write your electron arrangement. Okay. So why we need to learn 1s2 notation? So that we can locate the electron more, we can find the electron more accurately. Later, I will tell you. Later, I will tell you what do I mean by locate the electron more accurately. I will tell you more and more in a short while. Okay. All right. So this 1s2 notation, I will try to make it in something more easier. I call it hotel concept. Hotel concept. Okay. When you want to look for a person in a hotel, let's say today you are at a hotel, you are looking for me. How you can locate me accurately? So if you call me, Mr. Martin, where are you? So I only tell you, hey, I am now in second floor. Is it easy for you to find me? No. Imagine if the hotel is damn big. Imagine, okay, let's say this is the First World Hotel in Genting Highland. First World Hotel is damn big. It's one of the largest hotel in the world. According to the number of rooms they have, it's the largest hotel in the world with the most number of rooms. So imagine, I only tell you I'm in second floor of the hotel. How on earth you can find me? Imagine, second floor of the hotel got 400 rooms. You cannot find me one. Very hard. Are you going to knock the room one by one out of 400 and find me? Very hard or not. Okay. So hotel concept, we try to split into three parts: the floor, the section, and the room. So imagine today you call me, Mr. Martin, where are you? Then I tell you, okay, I am now in second floor of this hotel. I am now in section. Section means, let's say, north wing. I'm now at north wing of the hotel, and my room number is 208. Isn't that you can find me more easily or not? Okay, because now you clearly know which floor I am, which particular section I am, and which room I am, isn't it? For example, you go to a shopping center. Okay, maybe I just mentioned a shopping center that you guys might be more familiar. Okay, so I assume probably some of you here are from PJ. I assume that. All right. Let's say in PJ, 1U. Okay, One Utama. Okay, One Utama shopping mall. All right. So if you want to find me, where are you now? I am now in shopping mall. I'm now on second floor. You cannot find me one. Damn big leh. 1U shopping center is super big. It's very hard to find me. So what if I tell you I am now in 1U shopping center? I'm now at O Wing, second floor. Okay, O Wing, second floor. Okay, North Atrium. Okay, and then the shop 205. Isn't that easier for you to find me? Or not? So we learn 1s2 notation with one purpose only. We want to be able to locate the electron accurately. We must be able to find the electron accurately. That is what we are trying to do. That is what we are trying to do. Okay. So now we need to learn three important words. The first word is the floor. Okay. In the hotel concept, the floor is called shell. You learned about shell, right? Back in your high school. Okay. I got 281. I got 3 shells. I have 27. I got 2 shells. Okay, when you come to A level, we don't call it shell, but instead they use a more fancy word called principal quantum shell. Okay, we will learn about principal quantum shell. No worry, I'll show you what it is. After the floor, okay, you see in a hotel, you go for the floor. After the floor, sometimes we can cut the floor into different sections, right or not? Let's say you go to some shopping center. Most of the shopping center, they can cut into 4 sections, one according to 4 different directions. That's why you heard this. I am now at east wing, south wing, or not, or middle court, center court. north chord, something like that, isn't it? So that is called section. Section called subshell. So subshell. So subshell means what? The shell you can further cut into smaller part, subshell. So then we will learn something called orbital. Orbital means the room. What is the room that the electrons stay in? So no worry, I'll try my level best to make sure you fully understand what it is. I'm going to go very slow because, like what I say, it seems that today, most of you here didn't learn anything about 1s2 notation at all. So I'm going to go very, very slow to really make sure you can get some idea out of it. Okay, so let's start. Okay, so the first thing we will learn called principal quantum shell. So principal quantum shell is the shell that you learned back in your high school, okay, which is the circle. Okay, these are the principal quantum shell. Okay, so you can see, so in the middle of the atom, we call nucleus. In the middle of the atom, we call nucleus. So, and then the electron is outside the nucleus. All the electron, they are outside the nucleus. And then the electron, they are moving in all these circles. This circle called shell. So we know if the shell that is closest to the nucleus is called shell number 1. So then the further away, the bigger the shell number. Understand? Shell number 1, shell number 2, shell number 3, shell number 4, shell number 5, and so on. Okay, all right. So we know every shell, they can have maximum number of electrons or not. Every shell can only put in maximum number of electron. Okay, 1 minute revision. SPM and IGCSE. Okay, you tell me, guys. You tell me, first shell can put how many electron, everyone? First circle. First shell can put how many electron? 1 minute revision. 2 electron. Very good. So guys, second shell, second circle can put how many electron that we learned back in high school? 8, isn't it? Third shell can put how many electron? Third shell, also 8 electron. Okay, so basically, when we are in high school, we only learn 2 numbers, right or not? In high school, we only learn this. First circle can put 2 electron. Subsequent circle can put maximum 8 electron. That's why you learn about duplex and octet back in high school, isn't it, everyone? Correct? You learn this back in high school, but today you will learn something new that will really change your entire mindset and understanding. Your perception will be totally changed. Okay, so actually the third shell can put more than 8 electron. Actually, the third shell can put more than 8 electron. The fourth shell can put more than 8 electron as well. Okay, so actually how to do it? No need to memorize. You can use this formula. This formula called 2n power 2. 2n power 2. This formula can help you to calculate how many electron that every shell they can hold. How many electron that every shell they can accommodate. All right, the n here is the shell number. Remember, the shell which is closest to the nucleus is shell number 1, n equal to 1. The shell which is second circle, shell number 2, and so on. So you see, let's do mathematics. Let's do mathematics. If you put n equal to 1 into this formula, you will get 2, correct? First circle, first shell can put 2 electrons. Makes sense. That is exactly what we learned back in high school. Nothing wrong. If you put n equal to 2, so 2 power 2, 4 times 2, 8. Makes sense. So second shell can hold 8 electrons. Perfectly fine. Totally correct. Yeah, it is correct. Okay, it is correct. No problem. Okay. But now, let's look at it. Okay, let's look at this whole thing. Okay. So, third shell, 3. Third shell, 3. So 3 power 2, 9. 9 times 2, 18. Haha, you see? Actually, third shell can put 18 electron, not 3 and not 8. That's why, if you all remember, back in high school, what is electron arrangement for bromine? 2, 8, 18, 7, isn't it? You learned this back in high school. Okay? Okay? Bromine is 2, 8, 18, 7. And back in high school, we never know why. Why got 18 one? Why not 2, 8, 8, 7? Why is 18? Now you know already. So actually third shell can hold 18 electrons, not 8. Same thing, fourth shell, the fourth circle. So fourth circle, 4. 4 power 2, 8. Not 4 times 2. 4 power 2 is, okay, 4 power 2 is 4 times 4, 16. 16 times 2, 32. So the fourth shell can put 32. Now you learn something new, right? First circle can put 2 electrons. Second shell can put maximum 8 electrons. Third shell can put 18. Fourth shell can put 32. So can you see? The perception changed already. Because back in high school, we only thought first shell can put 2 electrons and all the subsequent shell, they can put 8. Now you learn something new. Okay, guys, let me know in the chat box. Are you okay with how many electrons you can hold in every shell? Let me know in the chat box. Are you okay? Every shell, how many electrons they can hold? This is something totally new for you. Totally new. Something totally new for you. Okay? That's what I keep telling you. Oh, when you come to your A level, you will see that something you were able to see something different, okay, compared to what you learned back in your high school. Okay, so that is what we need to know lah. Okay, all right, so we are done, okay. Okay, next one. So you can see here now. So imagine hotel concept. Remember I told you the principal quantum shell is the floor. So now you know. So your hotel look like this. The first floor of the hotel can put 2%. Second floor of the hotel can accommodate 8%. The third floor of the hotel can accommodate 18%. And then the fourth floor of the hotel can put 32%. So you can see this is your hotel. Okay. First floor, 2% maximum. Second floor, 8%. Third floor, maximum 18%. Fourth floor, 32%. Would they ask until fifth? No, very unlikely. Normally in A level, they will ask you all the way up to shell number 4 only. Very unlikely they will go until shell number 5. It's almost impossible for them to do so. Okay, next one. What about subshell? So subshell is this. Okay, when you go to supermarket, okay, one of the way to make it easy is what? Imagine, guys, now you go to a supermarket. So this supermarket is so big, like for example, One Utama Shopping Center, One Utama Shopping Center, 1U. Very big lah. So even I tell you now, I am in second floor. Very, very hard. Also, you find me, true or not? Second floor, very big lah. So now we will try to cut the hotel into 4 sections. Okay, like this one, this is the hotel. Like for this particular floor, you cut into different sections. Okay, tell me, let's say I am now in second floor. Okay, this first section, okay, or section A, second floor, section B, second floor, section C, second floor, section D, true or not? So same thing, why I want to do all these things? We do all these things with one purpose only. We want to able to locate the electron more easily. So imagine this, you call me Mr. Martin, where are you? I'm now in second floor. Very hard for you to find me. If I tell you, I am now in second floor, section A, at least you can narrow down. You know I am here. The chances for you to find me is much higher, isn't it? All right. So now we will try to cut every shell that we have into 4 sections. Okay, we will cut the floor, the hotel, every floor. We will try to cut into 4 sections. We will try to cut it into 4 specific sections. Okay, so what is it? Okay, what are the 4 sections? So imagine 4 sections in a floor of a hotel. Okay, so these 4 sections, we have a special name. We call SPDF. We call SPDF. Must use these 4 letters. Cannot use other letter. Not A, B, C, D. Must be SPDF. SPDF. Okay. So simple way to remember is what? Okay. So now I believe you guys are very familiar with PDF. All right. PDF. Okay. PDF notes. PDF exercises. SPDF. Super PDF. Super PDF. Yeah. SPDF. SPDF. Okay. And you can see the 4 sections are not same in size. You don't think like, this cake they must cut 4 sections equally. No, they will cut like this one. Small, bigger, bigger, and biggest. So they will cut unevenly. They will cut unevenly. Okay? All right. So I'll go on more and more. So I want you to know, so after we set up the floor, each floor of the hotel, now we want to cut the floor into a few sections. These sections is called subshell. Subshell. Just now the floor. What is the name of the floor? Shell, or we call principal quantum shell. Okay? So now let's go for it. So SPDF, so subshell means sections. Okay, how many sections we can cut in every floor? SPDF. Okay, so same thing. Every subshell has different number of electrons they can hold. This one, there is no formula to be calculated. This one, you cannot use the formula to calculate. Cannot. Okay. This one need to memorize, but there is a smart way to memorize. How to memorize is the SPDF. This is the maximum electron you can hold. So S can put 2 electrons. Make sense lah? Okay. The smallest shell can put 2 electrons. Okay. Subsequently, how many electrons you can put? I teach you a simple way. Okay. How many subshell you have? 4 subshell. 4 subshell, right? So here you plus 4. You plus 4. So when you plus 4, so now what happened here? P can put 6 electrons. So you continue to plus 4. You can put 10 electrons on the D. You continue to plus 4. You can put 14 on the F. Okay? So SPDF, okay? They have different sizes. S can put 2 electrons. P can put 6 electrons. D can put 10 electrons. And F can put 14 electrons. So a simple way to remember is S can put 2 electrons. And subsequently, you add 4. Plus 4, plus 4, plus 4, plus 4. Okay? So guys, let me know in the chat box, are you okay with what is subshell and how many electrons that every subshell can hold? Are you okay with that? So SPDF stands for what word? No specific word. No specific word. No specific word for it. Okay? All right. We just call it SPDF. Yeah? So I hope so far you guys can understand. All right. So every floor of the hotel, we cut it into a few smaller sections. This smaller section is called subshell. How many subshell out there? 4. 4 subshell, which is SPDF. And every subshell, they have maximum number of electrons they can accommodate. There's a maximum number of electrons they can hold. Yeah? All right. So now, okay, so same thing, you see? Now, this is the one. So don't memorize. I teach you how to use common sense to do. Okay? So you don't think every floor must have all the SPDF. No, not every floor has SPDF. So now, I teach you how to do it. How to do it. So everyone, look at here. Okay. First floor. Okay, so put it here. So first floor, second floor, first floor, second floor, third floor, and fourth floor. Okay, so all these floor called principal quantum number, the principal quantum shell, sorry. So the first floor, n equal to 1. How many electrons you can put? 2n power 2. You can put 2 electrons or not. You can put 2 electrons out there. Okay, you can put 2 electrons. Okay, so I put here 2 electrons. So second floor, you can put how many electrons? 8. Third floor, how many electrons we can put? 18. The fourth floor, how many electrons we can put? 32. Okay, now let us try to cut the section, or we call cut the cake. Let's cut the cake. So imagine you have a cake. Your cake, you must cut into SPDF, 4 different sizes. Okay, SPDF, 4 different sizes. 4 different sizes. Okay, so imagine this. Okay, all right. So the first shell can only put 2 electrons. So you can cut into what sizes? Remember, SPDF. S can put 2 electrons, P can put 6, D can put 10, F can put 14, right? Plus 4. Okay. So when you have first shell only have 2 electrons. when you only have 2 electrons, what cutting you can have? Only astronaut. Only S you can do, ma. Okay? Just imagine this, everyone. You have a cake. You want to cut the cake into 4 different sizes. S, which means you cut the cake into 2 meters. P, you cut the cake into 6 meters. D, you can cut the cake into 10 meters. And F, you cut the cake into 14 meters. So let's say on the first floor only got 2 electrons, which means first floor, your cake only 2 meters. So when your first floor only got 2 meters, what cutting you can do? Only S, astronaut. You cannot do P, ma, because P is 6 meters. You only have 2 meters. How to cut into 6 meters? Impossible, ma. So first floor only can cut into S. Only S size. Only S subshell. So the first floor only has S. Nothing else, true or not? Okay? Right, so second floor. Second floor got 8 electrons. So imagine now the cake's got 8 meters now. So now you have a cake which is 8 meters. So 8 meters, how to cut, everyone? So cut using the S first. So S, cut it 2 meters. So after you cut the S 2 meters. So how much you still left? Your cake is 8 meters. You cut 2 meters already. You still have 6 meters, right? So the 6 meters, can we do some other cutting? Yes. 6 meters can cut into P. So you can do another cutting here. This is P. So make sense lah. S 2 meters. P 6 meters. All together 8 meters. So now you know already. Second floor can put 8 persons. So the first 2 persons put in S. Another 6 persons put into P. Okay? So I stop here for a while. Everyone, up to this moment, are you okay? Up to this moment, can you see how I do the cutting? Up to this moment, are you guys okay? How I do the cutting? Okay, I go very, very, very slow just to make sure you really, really get it. Okay, what about the rest who are not replying? I hope everyone can reply so that I know you're okay or not. Is it okay? So guys, can you please, everyone, can you please reply to me? Do you understand so far up to first and second floor of cutting? Okay, Hannah? Okay, now let's look at the third floor. Okay, third floor. So third floor, how to do the cutting? Okay, third floor got 18%. Same thing like imagine a cake. Third floor, a cake. So now we have another cake. This cake is on the third floor. This cake, the total length is 18 meters. 18 meters. Okay, there are total 18% in this third floor. So how to do the cutting? So 18. So S got 2%. So after that, P got 6%. So now you can go for D. D got 10%. Am I right? 2 meter cake, 6 meter cake, 10 meter cake, add together 18 meter, which is exactly same as the third floor. Which is exactly same as the third floor. So third floor have 3 cutting. The third floor can cut S, can cut P, and can cut D. Can you see the size is different? You see? S, small size, P, bigger size, D, even bigger. So you don't think all the cutting same size one. We are not cutting the whole thing equally. Okay, we are not cutting the whole thing equally. All right? Okay, next one. Fourth floor. So fourth floor, how to do the cutting? Easy lah. Okay. So the fourth floor got total 32%. 32%, we can cut S, which is 2%. Okay. We can cut P, which is 6%. We can cut D, which is 10%. And lastly, F, 14%. Altogether, 32. Okay. As simple as that. Okay. So very easy to remember one. You see, first floor, 1 cutting. So when you only have 1 cutting, you write what I write here. See, first floor, only got 1 cutting. So what is the first letter? S. Second floor, got 2 cutting. S and P. See, second floor, S. Second floor, P. True or not? Second floor got 2 cutting, ma. Third floor, 3 cutting. S, P, and D, isn't it? Fourth floor, 4 cutting, S, P, D, and F. So very easy to remember, not? Okay, 1 floor, 1 cutting, 2nd floor, 2 cutting, 3rd floor, 3 cutting, 4th floor, 4 cutting. Okay, so when you only have 1 cutting, S. When you have 2 cutting, SP. When you have 3 cutting, SPD. When you have 4 cutting, SPDF. So everyone, let me know in the chat box, are you okay how I cut my hotel into all the subshell? Are you guys okay so far? Are you guys okay how I cut the 4 floors of my hotel into some smaller section? Can, this is super important. Okay, this is super important. Okay, now how are we going? Okay, so now after you do all the cutting, now it come to the blockbuster, the most important part now. We will start to fill in electron already. In a short while, you will learn this fancy thing, 1s2, 2s2, 2p6, all these things. Right, after 5 minutes, you will learn how to write this, okay? So now, you already cut your hotel into different floor. You already cut your hotel into different section. Okay, so now it's time. Now it's time to put the people into the hotel. You don't want your hotel vacant, isn't it? You don't want your hotel vacant. What is the purpose of hotel? Let people to stay. True not? Let the visitor, let some tourists to stay in the hotel. So now we will start to put the right person into the hotel. So what we try to put in hotel, we put electron. Okay, we want to put the electron in this special hotel. So how to fill in the electron? So you will learn something called parallel rule. So what is parallel rule? This is super technical. So listen carefully. So parallel rule, what is it? So parallel rule. So this parallel rule tell you the sequence, how you put in how to put in the gas into the hotel, because there must be a rule one. Like for example, today, let's say today you go to any hotel, there must be a rule one. Okay, like for example, they won't be so random one. Like for example, you go into the hotel, you go check in. Okay, I put you in room 208. Then the next person, all in sudden, I put in room 788. No way. Then the subsequent person, I put it at the room 108. Then the next person I put in a room 408. Cannot be so random one. There must be a law how they put in the person. For example, simple law is what? They must fill in a floor first. For example, all the people come to this hotel, I must fill in the first floor. Only when the first floor is full, we go on to the second floor. When the second floor is full, then only we move on to the third floor, the fourth floor, and subsequently. Am I right? I won't put you at third floor when the second floor still got empty space. I won't put you in fifth floor when the first floor still got empty space. This is a simple rule, okay? So this parallel rule, very important. So how to do it? Remember just now how I write it? Okay, everyone look at here. Open your eyes as big as possible. Listen to what I'm going to say. First floor, I told you, right? How many floor, how many cutting, right? First floor, how many cutting? 1 cutting, which is S. Second floor, how many cutting? 2 cutting, S and P. Third floor, how many cutting? 3 cutting, S, P, and D. True not? Fourth floor, how many cutting? 4 cutting, S, P, D, and F. So I want you to write this thing first. Then I want you to draw parallel line. Parallel line. Your parallel line like this. Is it okay? Okay. So this parallel line tell you what? The sequence, how you fill in electron. So imagine, guys, you are now a hotel reception. You sit at the front counter. So when there are many tourists come to you, let's say 100 tourists come to you. So how you know which tourist should go to which room? You follow this example. Let's say now there is electron come to you. So the first electron where you put at 1s first. You always put in 1s. So when the 1s already full already, then only you go to 2s. When 2s full already, you see, follow the arrow. Follow the arrow. Then you go to 2P. After the 2P is full already, you put the next person to 3S. After 3S full already, you put the subsequent person to 3P. After 3P full already, you put the subsequent person to 4S. Then after 4S full already, you put the subsequent person to 3D. After 3D full already, you put the next person to 4P. So you must follow this rule. This rule tell the sequence. You cannot be so random. Oh, these two fella put at 4S. Then the next two fella put at 1S. Then the next few fella put at 3P. Cannot be so random. So you must put the person to 1S. 1S full already. Then you move to 2S. 2S full already. 2P. 2P full already. 3S. 3S full already. 3P. 3P full already. 4S. 4S full already. 3D. 3D full already. 4P. If 4P full already, what happened? Go on, parallel line. 4D already. But for your level, normally it's impossible for them go up to 4D lah. Normally 4S is the end already. So everyone, let me know in the chat box, are you okay how to put in electron in the right sequence? Are you okay so far? So make sure you all know this magical parallel rule. This parallel rule very important. So whenever they want you to fill in electron, I want you to write this parallel rule. I want you to write this parallel rule so that you know exactly the sequence. Okay, now the best way to learn is by example. The best way to learn is by example. I will run through a few examples. I will run through a few examples together with you. Hopefully, this example give you guys a better idea. Hopefully, these few examples will going to give you a better idea so that you know exactly how to put in the electron in the right way. How to put in the electron in the right way or in the right place lah. Okay. So let me show you. Okay, let me show you how it works or how it can be done. Okay, so follow me. I'm gonna go very, very slow. Okay, come, let's start. Okay. Sodium. Okay, so today I have a person called sodium. Sodium got 11 electron. Okay, so back in high school we learned 281, but ladies and gentlemen, you are no longer in high school, right? We are no longer in high school. We are now at pre-university level, pre-U. So we don't write this anymore. So we will write something called 1s2 notation. Okay, in A level, we will learn something called 1s2 notation. So imagine everyone, there are 11 tourists. There are 11 tourists come to your beautiful hotel. You are sitting at the front counter as the reception. You want to put these 11 tourists to the right places, So how to do it? So everyone, common sense, 11 tourists. So first and foremost, where the electron should go? 1s. So 1s, so write 1s first. Ladies and gentlemen, S can put how many electron maximum? Let me know in the chat box. S can put how many electron maximum, everyone? S can put how many electron, everyone? Maximum 2, right? So imagine, you got 11 tourists. Okay, so you have 11 tourists like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You have 11 tourists. Okay, so now you have 11 tourists. So now you know, first of all, you must go to 1s first. So 1s, so you go to your hotel. Okay, come to my hotel. So my hotel here. Okay, all right. Okay, come to my hotel, please. Okay. So now my hotel. So first of all, we know we must go for 1s. 1s, S can put 2-person maximum. So 1s, 2. So you put the first 2 tourists to the first floor S. So not first floor S. Put it in here. Okay. After that, Now, subsequently, after the first 1S is full house already, then we have to move on to the second one. This one is full house already. So then we go on to what? 2S. So not 2S. So 2S. So 2S can put how many? All the S can put 2 person. Okay, so you see, by the way, just now we have initially have 11 person. When you put 2 person in the 1S, so now you left 9 person. So now we put another 2 person in 2S. So another 2 person go to 2 second floor and S. Okay. So now another 2 person go already. So you left 7 person, right? So let's continue. After 2S, where they go? After 2S, they go for 2P, right? They go for 2P. Okay, 2P. Okay, so now the next thing we want to put into 2P now. So 2P can put maximum how many? Everyone, P can put maximum how many? P can put maximum how many? P. P can put maximum how many, everyone? 6. P can put 6 person, right or not? So here, let's find 6 person. 1, 2, 3, 4. Okay. 5, 6. So these 6 person all will move to 2P. Am I right? Put here. So now the 2P here put 6 person. All good? Okay, now after that, you left 1 more person to go. 1 more person to go. Okay, all other 10 person already found their place in the hotel. So now we have 1 more person left over. So what to do? Okay, after 2P, where to go? After 2P, so you look at the sequence, look at the sequence here. Okay, you see here, all right, okay. All right. So look at the sequence, a parallel line, okay. So 1S, 2S, 2P, after 2P, 3S, true not? So now we go to 3S already. True not? You see, after 2P, the arrow is here, 2P, then 3S. Okay, 3S. Okay, 3S. So by right, everyone, 3S can put how many person? S can put maximum 2 person. But do you have 2 person to put? No. You left 1 person only. You left 1 person only. So this 3S, you put how many people there? Only 1. No problem, S can put maximum 2 person. Does it mean that it must be 2? No, just like you know. This hotel maximum can stay 2 person in a room. Must I put 2 person in a room? No. I can put 1 person also can, no problem, or not. Maximum can put 2 person. But it's okay if I put 1 person, or not. Because now I only left 1 person, I cannot go to put 2, isn't it? Only 1 person left. Of course, 1 person put in 3S. So now this 1 leftover person will go to 3S. 3S means 3rd floor S. So you can see all the 11 people already found their place. Okay. And this is our electron arrangement. How to know you are doing something fantastic? All these numbers add together, you should get back 11. That is exactly the number of electrons that we want to put. Ladies and gentlemen, are you okay with how 1s2 notation works by now? Can you see this thing used to be quite horrible about 30 minutes ago? Am I right? 30 minutes ago, you don't know what the heck is this. What the shit? 1s2, what they're doing. But now you know the logic already, isn't it? Okay? That's why we learn slowly and progressively. And you will be fine. You will be fine if you learn in a nice way. If you really, really learn slowly, you learn in a nice way, everything will be fine. Okay? So come, let's try another one more. Let's try another one more example. Calcium. Okay, calcium. Right, calcium. Calcium got 20 electron. How on earth we can fill in the 20%? So same thing, you see? Let's write your parallel rule. Everyone, come on. Let's write our parallel rule. So first floor, S. Second floor, 2 cutting, S and P. Third floor, 3 cutting, S, P and D. Fourth floor, 4 cutting, S, P, D, and F. So parallel line. True or not? True or not? Okay. So first and foremost, let's do it. 20%, 20 tourists come to the hotel. So where to put? 1s. So 1s, put how many? 2 person. So you have 20 electron, 2 person, put in 1s. So after that, you have 18 more. So now 2s. S can put maximum how many? 2 more. So you have 16 person to go. So now after 2s, you go for 2p, right? True or not, you see? 2s, arrow, come to here, true or not? Then you go for 2p. P can put how many person maximum? 6. So you left 10 person. So after 2p, subsequently, where they go? 3s. So 3s. So S can put how many person? S can put only 2 person. So you have 8 more to go. Okay. Then what else? After 3S, subsequently, come here, 3P, right? So 3P. P can put how many person maximum? 6. So you left 2 person. Am I right? So then after 3P, subsequently, 4S. So 4S. S can put how many person maximum? S can put 2 person maximum. Do you have 2 person to put? Yes. So exactly finish. So that's how we do it. So this entire thing is called 1S2 notation. And I really, really hope you guys have some rough idea how to write the 1S2 notation by far. Okay, I hope up to this moment, you all know how to write this 1S2 notation already. It's not very, very hard. Most importantly, you do it slowly, you do it carefully, and you will be fine. Okay? You will be fine. Okay, let me go through a few more examples. Then I will let you try some exercises all on your own. Huh? All right. But I really, really hope you guys can get some rough idea. Okay. If we write SPDF in capital letter, will they deduct the mark? No, they won't deduct your mark. They will give you 0 directly. Huh? Okay. Your SPDF must be in small letter lah. Must be in small letter. If let's say you write 3D big letter, totally no mark. Huh? Totally no mark. Because other thing very hard to see. You see S big or small capital letter is the same thing, so they don't care lah. P, the small or big letter, they don't see much or not. You see S, P, D, F. Basically, these two big or small capital is the same. Now these two, if you go to write F in a big capital, 0. D in a big capital, 0. Must be all in small capital letter. All in small letter. All small letter. Yeah? All right. So now we are done with the 1S2 notation. Okay, now we go on a little bit more. Still 1S2 notation, but go more detail. Huh? Okay, sometimes the 1S2 notation is damn long. Sometimes, you see, sometimes the 1S2 notation can be like this. 1S2, 2S2, 2P6, 3S2, 3P6, okay, 4S2, 3D10, and 3 and 4P3, for example. Sometimes it can be super duper long. Yeah. All right. But not worry, no worry. Just follow back the parallel rule only. Just follow back your parallel rule, then you will be fine. Is okay? Right. So now that's why sometimes when it goes super, super long, when the answer go very lengthy, we can save some space one. Okay. We can actually use noble gases arrangement to save some space. We can use noble gas arrangement to save some space. Okay, what do we learn? What we know about noble gas? So noble gas is the last group in the periodic table. Okay, noble gas is the last group in the periodic table, group 18. And we know noble gases, they are very stable. So there are 3 important noble gases that we learned back in high school. Helium, which got 2 electrons. Neon got 10 electrons, and argon got 18 electrons. You don't need to memorize, because in the real examination, they will give you the periodic table. Okay, in the real examination, they will give you the periodic table. So the periodic table will be given to you. Yeah, the periodic table will be provided to you. So no, you not even need to memorize. I just need to look at the proton number. Helium is 4 and 2, so it's 2 lah. Okay, neon, here you can see, oh, all right, so this is 10, for example, and 20. Yeah, you can really, really go and see the proton number. So you know already, helium, neon, and argon, they are noble gases, and this is the number of electron they have. Okay, now, how are we going to save some space? How are we going to save some space? Example, you can see, now sodium. Sodium, just now when we wrote it, is here, sodium, right? Okay, sodium, just now, when I wrote it, it's like this. Okay, so it's 1s2, 2s2, 2p6, and 3s1. Okay, so you can save some space. You can save some space. Okay, how to save some space is here. Okay, so here, helium got 2 electron, neon got 10 electron, argon got 80. So 2 electron, more than enough. So 10 electron still can, because you have 11, isn't it, in total? 18 cannot. Okay, so we go for the biggest number that we can save that is possible, which is 10 electron. So that's why here, where is the 10 electron? This one, true not? 2 plus 2 plus 6, 10 electron. So this 10 electron, if you're lazy, you don't want to write it up, you can do this. This 10 electron, you can save some space like this. This 1s2, 2s2, 2p6, total 10 electron. 10 electron equivalent to neon. You can put a square bracket and neon. So which means this whole thing is simplified into neon already. So neon got 10 electron here. So then the 3s1 you copy. So this is how you save some space. This is how you save some space. Okay? As simple as that. But if you ask me, I prefer you write everything lah. But I need to teach you this so that you won't feel shocked when you see this in your textbook or reference book. How come they put bracket and NE? What is it? Okay? So guys, let me know. Are you okay what I am doing here? Do you understand what I am doing? Do you understand how I use neon to save the space? Are you okay with that? Okay, we try one more. We try one more. The calcium. Okay. We can use any noble gases, correct? You can use any noble gases, yeah? But normally they ask you helium, neon, and argon, all right? Helium, neon, and argon, okay? So let's look at another one, calcium. So calcium just now got 20 electron. When I write it out, is 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2, isn't it? Just now, when I write it, this is the 20 electrons. So I can save some space, right or not? Helium, it's 2. Neon, it's 10. Argon, it's 18. So here got 20. What is the biggest number of noble gases we can save? 18 or not? Okay, the biggest number of noble gases we can save is 18. Where is 18? Here. So this entire part is 18. So which can be simplified using a argon. Then this whole thing here is not simplified. You copied it. So this is the 1s2 notation for calcium after simplification. After simplification, that is what we got. Okay? So now we already know how to do the simplification. Okay? How to do the simplification. Okay? All right. So guys, now your turn. Okay, now your turn. Okay? So I'll give you probably about 2 questions for you to practice on. I'll give you 2 questions for you to practice on. So one question, I don't want you to do the shortcut. Another one, I want you to do the shortcut. Okay? All right. So the first one, I want you to try to write for me the electron. I want you to write the 1s2 notation for aluminium. Aluminium got proton number 13. Number 2, I want you to go and write for me the electron arrangement for potassium. Potassium is 19. Okay? So this one, I don't want you to use short. This one, no. Okay. This one can use shortcut. Or maybe this one, no shortcut. This one, shortcut. Shortcut means noble gases arrangement. So guys, give you about 1 or 2 minutes, take your time, and I want to see your answer in the chat box. Can you please write the 1s2 notation for me for the aluminium and potassium? Use whatever thing I taught you today. Use all the concepts that we learned for the past, 40 minutes. Yeah, come on, try to work on it. Try to work on it. Yeah, and I'm waiting your answer. Yeah, I'm waiting your answer in the chat box. All right. It doesn't matter your answer is correct or wrong. It doesn't matter. Most importantly, you try and you show me the answer. At least even you are wrong, I can point out your mistakes. Okay. But if you're not replying, you didn't let me know your answer, I couldn't comment whether your answer is correct or wrong, isn't it? Chona, I say first one no shortcut, second one shortcut. I say second one shortcut. Okay, so let's discuss. So remember how we write it? So write the parallel rule. 1S, 2S and P. Third floor, SPD. Fourth floor, SPDF. And you go for your parallel rule. Okay, so let's go. So 13. So 13 electron. So 13 electron, 1s2, 2s2, 2p, 6, 3s2. Okay, so and then 3p, 1. Okay, that's it. So that's how we try to put in the electrons into the aluminium. So I can see so far error is okay. Based on the answer I saw in the chat box, is all good. Next one, potassium. So potassium got 19, 1s2, 2s2, 2p, 6, 3s2, 3p, 6, and 4s1. Okay, so this is the full arrangement, but I want shortcut. So when you have 19 electron, the nearest shortcut you can use is 18, which is argon. Helium got 2 electron, neon got 10, argon got 18. So go for the nearest number you can shortcut. So 18. So 18 it's here. So after shortcut, the 18 simplified into AR, and then the 4S1 you copied it. And this is how it works. Okay? So now I hope everyone gets some rough idea what is 1s2 notation. Okay? So now let's go on a little bit more. Okay, let's go on a little bit more. So now we will start to learn some special case. We will learn some special case. Okay, be very, very careful when the electrons arrangement involve d subshell. Okay, be careful when the electron involve d subshell, because so far you can see everything that I wrote here, they didn't have d subshell yet, true or not? Everything that I wrote just now, okay, so we didn't have a d subshell yet. Okay, we didn't have a d subshell yet. Okay, so now we want to see how it works. Okay, we want to see how it works here. All right. Okay. Okay. So now I'll give you this special example. You see, All right. Iron. Iron got 26 electron. 26 electron. So 26 electron, if you use the 1s2 notation, how to do it? Okay. You see, 1s2 notation, 26 electron. Okay. 26 electron. So 1s2, 2s2, 2p6, 3s2, 3p6. Okay. After 3p, 4s2. You see, after 4s, jump back to 3d. 3d6. So add together 26. So if you use the parallel rule, this is the answer we get. This is the answer we get. But you have to be careful. Okay? When you see got d orbital here, you need to do some rearrangement, because you see this thing, nothing wrong. Perfectly fine. Perfectly fine. But you need to do some rearrangement. Why? See, it doesn't look beautiful. Why? First floor, second floor, good. Third floor, fourth floor. Jump back to the third floor again. Doesn't look nice. Doesn't look nice. So you see, this is so special. You see, when you fill in 4s, then only 3D. Nothing wrong. Nothing wrong with the sequence. You fill in 4s already, then only 3D. Nothing wrong. And that is exactly what I have done. That is exactly what I have done. I fill in 4s, then only 3D. But when you write, try to write in a beautiful way, like first floor, second floor, all the way, third floor, all the way, fourth floor. So when you have something like this, whereby you see, this arrangement is okay, but it looks not so beautiful. This arrangement, nothing wrong. This arrangement is correct, but it's not so beautiful, because fourth floor, third floor, not good, ma. You want all first floor, second floor, third floor, all the way there, only fourth floor or not. So maybe you can rewrite, beautify the whole thing, rewrite. So when you rewrite, you can just put it like this. Okay? Just rewrite. So that first floor, second floor, all the way. Okay? Third floor, all the way third floor, and only fourth floor. So this is called beautification. Beautification. So you only need to do the beautification whenever there's 3D. When you have d orbital, you need to do the beautification. If there's no d orbital, everything will be arranged nicely. You see, first floor, second floor, okay, third floor, fourth floor. Beautiful one. So only the d orbital. D orbital is like, okay, the culprit. They kacau one. They will create problem to us. They make the arrangement not beautiful when you have the d orbital. So that's why when you have d orbital, you need to do one more baby step, which means after you wrote the electron arrangement, you need to do one more extra step, beautify. Beautify means what? Move the 3D in front, move the 4s to the back. Just make it more beautiful. Okay, Everyone let me know in the chat box, do you understand what I means by beautification here? What I means by beautification? Do you understand that? Do you guys understand what do I mean by beautification in this case? So I get a question, sir, if I don't beautify it, would it still correct? No, it's wrong. It's wrong. If you don't beautify, they will mark you as wrong. Previously in the old syllabus means before year 2022. Before year 2022, even you write the whole thing without beautification, correct. But starting from year 2022 and onward, you must beautify, must. If you don't beautify, then it is wrong. So remember, when you have d orbital appeared, you need to do beautification. You need to do beautification. Finish. Okay? All right. So now let me teach you the last thing for tonight. Let me teach you the last thing for today, for today's lesson. Okay. So now I already teach you how to write the electron arrangement, isn't it? So now, what happens if I want to write electron arrangement for ion? So just now all the 1s2 notation that we discussed, they are all for atom. They are all for atom. Atom means neutral. But what if they want us to write 1s2 notation for ion? Example, the question asks, write the 1s2 notation for aluminium ion. Write the 1s2 notation for O2, oxide ion. So how on earth we do it? It's the same thing. So how to write the 1s2 notation for ion? Start with the atom. So write the 1s2 notation for the atom, which is neutral. Then only you donate or receiving electron to make it ion. So start with the 1s2 notation for the neutral atom. Start with the 1s2 notation for the neutral atom. Then only you donate electron to make it positive ion, or you receive electron to make it a negative ion. Yeah. So that is what we need to do. All right. Example. So I'll run through 3 examples together with you. First example, I want to write the 1s2 notation for aluminium ion. So in the first place, you have to start with atom. So let's write the 1s2 notation for aluminium atom. So aluminium atom got 13 electron. So this is the 1s2 notation for the aluminium atom. So when I want to get aluminium ion is Al 3 plus, right? So how to become Al 3 plus? Donate 3 electron. So where the 3 electron that you donate? So when you donate the electron, donate the electron from the right hand side first, you see. So 3 electron, I want to throw 3 electron. So I throw 1 electron here first. Throw not. Okay, throw already. After throw 1 electron, so I can throw another 2 more electron here. So I throw total 3 electron. So I throw these 2 away. So this is the leftover. So 1s2, 2s2, 2p6. Okay. So when you donate or receive electron, always do it from the rightmost subshell. So look at the rightmost subshell. This is where you donate or receiving electron. Okay. So I want to throw 3 electron. I throw 1 electron here. After that, throw another 2 more here. So total 3 electron I threw away. That's it. So everyone, let me know in the chat box, are you okay how I write electron arrangement for aluminium ion? Are you guys okay how I get the 1s2 notation for aluminium Al3 plus ion? Are you guys okay with that? Do we need to throw it before or after beautification? Throw it before beautification. Always do this before beautification. That's a good question. But again, this one no need to beautify, because beautification, you only do it when there is a d orbital. There's no d orbital here, isn't it? So there's no beautification issue at all. Later, I'll show you the question which got beautification. Good question. Okay, let's look at here. Next one, example 2. Write the 1s2 notation for O2 minus oxide ion. O2 minus oxide ion. So first and foremost, even we want the electron arrangement for ion, we need to start from atom. We need to start from atom in the first place. So my atom is oxygen atom. Oxygen atom got 8 electron. So 8 electron, if you write the 1s2 notation using the parallel rule that I taught you today, this is what you will get. 1s2, 2s2, 2p4. 1s2, 2s2, 2p4. So now we know that from the oxygen atom, I want to get O2 minus ion. We learned before, when you want to change something neutral to become negative ion, when you want to change something neutral to become negative ion, you need to receive electron. So the charge is 2 minus, which means that you need to receive two additional electrons. So we need to receive 2 electrons. So who donate, who receive electron? From the rightmost. So the 2p, p can put 6 electron in total, right? So you can put 2 more inside, am I right? You put 2 more. So 4, you put 2 more, 6. Okay, so that's exactly what we can do. So not, okay, we have 4 electron here, you can put 2 more inside, 6. Makes sense, ma? P can hold up to 6 electron, which perfectly makes sense for us. So now we already get 1s2, 2s2, 2p, 6. Okay, so this is the electron arrangement for your oxide ion, O2 minus. Lastly, write the 1s2 notation for Fe3 plus ion. Write the 1s2 notation for Fe3 plus ion. So same thing, we cannot start with Fe3 plus immediately. We cannot start with Fe3 plus ion immediately. So we have to kickstart from the atom. Fe, iron. Iron atom got 26 electron. So if you write the 1s2 notation, this is what we get. And this one got the got d orbital. So you know you need to beautify. Okay, so don't need to beautify yet because I want to make it ion. So you only beautify after you make it ion. After you donated the electron or receive electron, then only you beautify. So what I want Fe3 plus. So Fe3 plus. So I donate I donate 3 electrons or not. To make Fe3 plus, I need to donate 3 electrons. So where do you donate 3 electrons? The first 2 electron throw from here. After that, throw 1 more, right? From here. So here got 6. You throw 1, you become 5. So after throw, I get this whole thing. Do I need to beautify? No need, because nicely. First floor, second floor, third floor. Very nice. So you see, so don't beautify before you donate or receive electrons. So don't do this. Don't put the 4s here. Hey, don't do like, okay. Sorry, my bad. Okay, I should say like this. Okay, I should say like this. Sorry, my bad. Okay, only donate or receive electron. Okay, only donate or receive electron after you beautify. Sorry, my bad. Okay, only donate or receive electron after you beautify. After you beautify, because you see, right, before beautification, you will write this 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d6. Okay, this is what I wrote, right or not? So you cannot donate 3 electrons from here directly. Cannot, because you're not yet beautified. Sorry, my bad. My apology. Beautify the whole thing first. So beautify the whole thing first, then only you donate or receive electron. So now, do we need to beautify? Yes, we need to beautify. Okay, we need to beautify. So first floor, second floor, third floor, fourth floor, third floor, not good. Beautify. So this is the electron arrangement after our beautification. So beautify first. Sorry, my bad. Just now I say wrongly. My bad. Okay. So after the beautification already, then only you start to throw the electron. You throw 2 electron here and 1 more electron here. Here got 6, throw 1 more, become 5. So that's why in the end, the answer here got 5. Okay, let me know in the chat box. Are you okay with this? Are you okay with the concept that you only throw or receive electron after beautification? Are you guys okay with that? Okay, so not very, very hard. So with that being said, we are all done. We are all done with the 1s2 notation. Okay, so I hope everyone know how to write 1s2 donation by far for your atom as well as for your ion. They are not hard. They are not hard. Most importantly, you understand. You understand the logic, how it works. Then you will be fine. Okay? So let's do a quick summary what we covered for the past lesson, for today lesson so far. So today lesson, today is the first lesson of your A level, AS syllabus. So we started with some honeymoon thingy. We learned about atom as the smallest particle. We learned that there are something smaller inside the atom, which is called subatomic particle, proton, neutron, electron. We learned about their symbol, their mass, and also their charge. Okay. So we also learned the behavior of proton, neutron, and electron. Neutron is neutral, so it won't be deflected in electric field. Proton is positive charge, it will be deflected to the negative side of the electric field. Electron is negative charge, it will be reflected to the positive side of the electric charge. And because electron is lighter compared to proton, electron deflect a lot. Electron deflect in a larger angle compared to the proton. Okay, so we also learn about standard representation. We also learn how to get proton, neutron, electron from the standard representation. We also learn something neutral donated electron become positive ion, something neutral receiving electron to become negative ion. Yeah, we learn about isotopes. We know that isotopes same chemical properties and different physical properties, and the chemical properties is due to same number of valence electron. So we also learn the most important thing today, which is 1s2 notation. So we seldom write 281 already in A level. We will prefer to write 1s2, 2s2, blah, 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 blah. This is called 1s2 notation, something totally new in your A level study. Why we need to use 1s2 notation? So that we can locate the electron accurately. We can find the electron more easily. Because previously, if you only have this 281, I only know, oh, today if I want to find the electron, I only know the electron is in the first floor, in the second floor, or third floor. That's it. I only know which floor they belongs to. Okay. So let's say I want to find the electron in here, which is one of these 8 fella. So I only know the electron is in the second floor. Very hard to find. I asked you to find me in the second floor of One Utama shopping center. Very hard for you to find me. Am I right? So, but now when you have 1s2 notation, you will know I am now in the second floor of the shopping center. I am now in which section of the shopping center. So you can find me more easily. This is the reason why we learn 1s2 notation. Okay, so today we learn what is principal quantum shell. Okay, so which is the floor in the hotel. So there's maximum number of electron in each floor. We use 2n power 2 to calculate it. So we also know subshell. So every floor can cut into 4 smaller section, SPDF. So SPDF, they have different number of electron they can hold, 2, 6, 10, and 14. So all the number add by 4. So then we know how to cut our floor into all the section. We learn about important parallel rule and how to write the 1s2 for atom and ion. And remember, if your 1s2 notation inside got D, if your 1s2 notation inside got D subshell, you need to do beautification. Beautification. Yeah? And that's it. So I hope you learn something in the first lesson of A-level study with me. Okay, guys, let me know in the chat box, how's everything? How's your first lesson of A-level study so far? How's your first lesson in your A-level study so far? How's everything? It's not very hard, okay? If you learn in the right way, you will be fine. Okay, if you learn the right way, you'll be fine. But remember what I said just now, in A level, you have to start doing past year question as early as possible. Okay. So I get a question, do we need to purchase topical question from Shopee or just past year question from internet? Depends on you. It all depends on you lah, okay? If you think you need the topical question from Shopee, you prefer to have the hard copy, then you just simply purchase lah. All right. But if you feel that by using those online resources, you can print yourself, perfectly fine, no problem one. You decide yourself. Okay, you can decide yourself. All right. So there are many ways to do that. Okay, it's all up to your personal preference. Okay. Okay, so guys, I think with that being said, we are all done. Yeah, we are all done with the first lesson of your A-level study. Hope you learned something today, and I'll see you again in the next lesson.